grams of nitrogen from the periodic table is 14.01. So 14.01 grams of nitrogen is equal to 1 mole of nitrogen. My grams of nitrogen get to cancel out. Now 9.52 divided by 14.01 comes out to 0.679. Remember, let's go back 3. If it's just a decimal and doesn't have a whole number in front of it, and it's only a decimal point, let's go ahead and put 3 numbers. After that is oxygen, and we're going to change that to 27.18 grams of oxygen. Go to the periodic table, and we normally just change that to 16 grams of oxygen is equal to 1 mole of oxygen. Now my grams of oxygen gets to cancel out. Let's go ahead and do our math there. So 27.18 divided by 16 comes out to 1.69. Okay? So here's where I'm at. What do I do on the next step? I'm going to divide all of those numbers by the smallest number. That's what step 3 tells me. So this is the smallest number. So divide this by 0.679, divide by 0.679, divide by 0.679, divide by 0.679. Let's go ahead and let's do that. So 1.69 divided by 0.679 comes out to an answer of 2.5. Oh. The next one, that number divided by itself equals 1. The next one, 6.09 divided by 0.679 comes out to 8.97. And then the next one, 4.75 divided by 0.679 comes out to 6.99. Okay, not too bad. There's a problem. My problem is do you see how I pretty much 1.995, we rounded it to 2? Well, 6.99 can pretty much get rounded to 7. And 8.97 is so close we can round that to 9. But I cannot round 2.5. 2.5 is in the middle. So when it says, when we have a problem here, let's go to step number 4. We need to multiply till it's a whole number. Okay, so 8.97 is pretty much a whole number to 9. I mean, so much little more. It can be rounded up. But 2.5 cannot be rounded up. So multiply all the values from number 3, step 3. Here is step 3 right here, by the same number until it produces a whole number. Begin with a small number. Well, I'm not going to multiply by 1 because I'll get 2.5 again. So what's the next smallest number? Let's multiply by 2. So 7 times 2 equals 14. 9 times 2 equals 18. 1 times 2 equals 2. 2 times 2.5 equals 5. Do I have all whole numbers? Yes, I do. That is the empirical formula for NutraSweet. So my answer comes out to, let's go ahead and write them in the elements in that order. C14, what's the next one? H18, what's the next one? N2, oops, sorry, can't see that very clearly. O5. That is the empirical formula. Again, it's going to take some practice. Let's come on this side and let's keep looking at empirical formulas, and then we'll go to molecular formulas. So looking at our empirical formula. It says here that empirical formula is actually the chemical formula written in the lowest atomic ratio possible, right? Because it's reduced. A formula giving the proportions of the elements present in the compound, but not the actual arrangement or numbers of atoms, right? Because this is reduced. So the empirical formula for glucose is C1H2O1. That does not mean that there's only one carbon. There's not. This is just the reduced form of glucose. So if you're given the percent composition for the elements, assume that you have 100 grams, just like we did on the previous page. Multiply it by the atomic mass so we can find the moles, right? So convert mass to moles. And then after that, we're going to divide all of the numbers by the smallest value. And then if we have a problem because somebody's like 0.5 or 0.6, it's not 0.99, then we're going to have to multiply by number 2 and then go to number 3 and go to number 4 until we get a whole number. Okay? So let's go ahead. So it says if you've got a decimal value close to 0.3 or 0.5 or 0.6 or 0.7, then we're going to have to go ahead and multiply that, right? So let's go ahead and let's do this one. We've got C, H, and O. Determine the empirical formulas. I'm going to let you do. And practice. I have no problem going through and setting you up and kind of helping you first. So let's do a little bit of setting up. Next problem. I have 170.0 grams of a sample, of an unknown sample, it says, and it contains 29.84 grams of Na, 67.49 grams of chromium, Cr, and 72.67 grams of oxygen. What is the empirical formula? Well, in that case, I'm going to go ahead first, and I'm going to convert mass to moles. So Na, which is my first one, 29.84 grams of Na. Go to the periodic table for sodium's 22.98. So 22.98 grams of Na is equal to 1 mole of Na. Okay, so 29.84 divided by 22.98 comes out to 129.85. All right, let's keep going. The next one is chromium, 67.49 grams of chromium. Let's go to the periodic table to find chromium, which here it is, 51.99. Alrighty, so 51.99 grams of chromium is equal to 1 mole of chromium. Oops, grams of Na canceled, grams of chromium cancel. Go ahead and do the math. 67.49 divided by 1.29. The next one is oxygen, 72.67 grams of oxygen. 16 grams of oxygen, because that is on the periodic table. My grams of oxygen cancel out, and this is equal to 1 mole of oxygen. Go ahead, 72.67 divided by 16 comes out to 4.5. What's the next step? You divide by the smallest number. Smallest number is 1.29. So 1.29 divide by 1.29 divide by 1.29. Finish the rest off. Okay? Let's look on the next part because we're getting into molecular formula. Molecular formula is the chemical formula written with the actual atomic numbers. A formula giving the actual arrangement and the numbers of atoms in that compound. So now the molecular formula for glucose is C6H12O6. The empirical is C1H2O1. It is reduced. Now it says here, though, there's a few steps. To find the molar mass, or number one is to find the molar mass of the empirical formula. Use the molar mass given in the problem. Divide by the empirical formula's molar mass. It says here, use the quotient, I can't even think, it's already so late, as a multiplier of the empirical formula's subscript. Sorry, I'm so tired. Rewrite the chemical formula. I'm so sorry. Forgive me. Let's practice this. I know I'm not even saying the steps clearly for you. The molar mass of trichlorosilane acid, whoa, that's a horrible name. I'm not going to even be able to pronounce that correctly, is 232.41 grams. Now, if the empirical formula is OCNCl, what is the molecular formula? Okay. Oxygen. What is the mass of oxygen? Remember, we rounded up to 16. What's the number that they gave us over here? They gave us a number 1. It's just invisible. So that's 16 grams. Let's go to the next one, carbon. Go to the periodic table, 12.01 times 1 equals 12.01. But that 01 is so small, it's like insignificant. The next one, nitrogen. Again, they gave us 1. And go to the periodic table, 14.00 or 14.01. So 14.01 times 1 equals 14.01. Again, those 0.01 is so small, it's insignificant. And the next one is chlorine. They gave us 1 chlorine. Go to the periodic table. That is a non-metal, 35.45. So 35.45 times 1 is 35.45 grams. Okay. Go ahead and find the molar mass by adding them all together. So 16 plus 12.01 plus 14.01 plus 35.45 equals 77.47. Alrighty. Grams, which is the molar mass for that compound. Again, they gave us the empirical formula. We're looking for the molecular formula. So what I'm going to do is I'm going to get the number that they gave us, which is the amount of 232.41 divided by the molar mass that we found of the empirical formula that we have, which is 77.47. So let's do that math. 232.41 divided by 77.47 comes out to 3.0. So in that case, my number is going to be 3. All right? So I don't need to change anything else because it's going to be 3 all the way around. So why is it 3? Because this is 1, 3 times 1 is 3. 3 times 1 is 3. 3 times... If it was a 2, then we would do 3 times 2, and that would be a 6. But since all of them are the number 1, 3 times that little number 1 equals O3, C3, N3, Cl3. That's my answer. Crazy, huh? Alrighty, the next one. We're talking about hydrocarbon, which is CH. Alrighty. They gave us, and they found that the molar mass is 78 grams per mole. What is the molecular formula for hydrocarbon? Well, let's break it down first. And we know it's carbon and hydrogen. So carbon, which has a mass of 12.01. And how many? There's only one because there's a 1 behind it, times 1. The next one, hydrogen, which is 1.01 times, look at this, there's a 1 behind it. So 12.01, 1.01, add them together. It comes out to 13.02 is what I got, which is the molar mass. But they told me that the mass of the sample that they have is 78 grams per mole. I'm sorry, again, I'm getting a little tired. So 78 divided by 13.02 comes out to, and that 0.02 is very insignificant. Comes out to 5.99, right? Which we can go ahead and just round that up to 6. Is there a number that's behind it? There is, the number 1 and the number 1 over here. So we're going to do 6 times that number. So C6H6 is the molecular formula for hydrocarbon. How about that? Let's keep going. We're almost done. I know. It's exhausting. I'm exhausted too, believe me. Molecular formula. How do you determine the molecular formula? So to determine the molecular formula of a compound, you must know the compounds. I'm so lost. The compound's empirical, sorry, I was lost for a moment, formula, and the molar mass of the compound. So they gave us a few steps, which we already saw those steps on the previous page. Determine the empirical formula if it has not been given. Okay, calculate the molar mass of the empirical formula. Use the molecular formula mass, which is normally given to you, and divide it by the empirical formula that you calculated. Okay, so that way you can get that number. Then you're going to multiply that number by the empirical formula number that they gave you, that little subscript. So if it's a 1, then you're just going to divide it by 1. But if it's a 2, then you're going to divide it by 2. Okay? So you get that 2 times whatever number. But let's practice. These are a few other ones here. What is the empirical formula of this compound? So I'm going to let you do this one. I'll do this one with you down here. What is the molecular formula for NutraSweet? Now, don't forget, we just talked about the NutraSweet, right, on the previous page. Now, they gave us the molar mass over here. First thing is, we need to go back and, do we know the, my mind went blank for a second. Do we know the empirical formula? We actually do. The empirical formula is on the previous page. Where did we find it at? For NutraSweet. Previous page. Here it is. C14 H18 into O5. C14. Oops. H18 into 0.05. Okay, so that's the empirical formula. Now, let's go ahead and let's do this. So we're going to pull every single element, carbon. How many do we have? We have 14. We're going to multiply it by the mass in the periodic table, which is 12.01. That comes out to 168.14. Next one here, we have is hydrogen. We have 18 of them times 1.01. So that comes out to 18.18. The next one is nitrogen. We have 2 of those. And go to the periodic table, 14.01. Multiply that. That comes out to 28.02. Let's keep going. Oxygen, we have 5 of them. Remember, that's 16. And so 16 times 5 comes out to 80. We're going to add them all up together. I get 294.54 grams. Now, they gave me their number, and I got my number. So what am I going to do? I'm going to get those numbers, and I'm going to divide them. But I'm going to put their number over mine on top of my number. So their number is 294.30. My number is 294.54. Let's do that because those numbers are pretty darn close. So 294.30 divided by 294.54 equals 0.999, which what can we do with that number? We can round that to 1. So now let's go ahead, and this is the number that we're going to multiply by the little subscript. C14, so 14 times 1 is 14. 18 times 1 is 18. N times 2 is 2. O times 5 is 5. So what is my molecular formula? C14H18 N2O5. There we go. You can do the previous step. There's not a lot in this foldable for you to do on your own. I'm doing most of it with you. What is a molecular formula? All right, so we're still talking about that. Molecular formula is the actual formula, okay, for that compound. So for an example, H2O, water. What is the molecular formula? H2O. What is the empirical formula? Reduced. I can't reduce H2O anymore. Hydrogen peroxide. The actual formula is H2O2. And I'm going to just use the word actual. That's the actual one. This is the reduced. And so if I can I reduce the 2's? I can reduce them to 1's. HO. This is glucose. Can I reduce this? I can reduce this and that. Divide them all by 6. CH2O. N2O1. Can I reduce it? I cannot reduce the 2 and a 1. They're as reduced as it can be. C8H10N4O2. Can I reduce it? Yeah, I can reduce this. I can reduce them all by dividing it by 2. So divide that by 2, which is 1. Divide that by 2 is 2. Divide that by 2 is 5. Divide that by 2 is 4. Here is the empirical formula. Look at that. Okay, you know how to reduce. So it says here, based on the table above, how is a molecular formula different from the empirical formula? Okay, I'm going to expect for you to do that because there's not any math. You can do that. Based on the table above, can the molecular be identical to the empirical formula? Answer the questions. Definition. The molecular formula may be the empirical formula, or it may be a whole number. Oops. Sorry. a whole number multiply of the empirical formula, right? Because if it was 1, then 1 times 2, and then you would do that. So you're going to go to look at the empirical formula and go and look at what the subscript is, and then we'll multiply by that. Okay? So you've got a couple of things there to do on your own. Now, on your foldable/lab, you've got 2 sections here, or 2 labs. It might take you a little bit to get it done. We've got moles of chalk, and then we have just how many in a mole. Okay, so we've got these 2 labs. I'll talk about them in lab and go over the directions. You really just need to do the mass weighing, and then you can do the actual calculations later on at home. Okay, other than that, we went through all the notes here. I know it's a lot. I apologize. But I know empirical and molecular formula is something completely new to most of us. Moles and conversion is something that we've already talked about. But again, we're taking it up to another step, another level, because we're going to get to what we call stoichiometry soon. Okay, have a great day. Bye-bye.